Alright, section 4.2, we're going to be going over least squares regression. The objectives: number one, find the least squares regression line, use it to make predictions, interpret the slope and the y-intercept of the least squares regression line, compute the sum of squared residuals. So, similar to what we were doing in section 4.2, we'll be given some data and we'll perform some computations with it. So this is showing you how to find the slope using slope formula, and then we'll use this method to find the equation of the least squares regression line. So here's the approach: 2 points, find the slope contained in them, use point slope formula, find an equation, express that in slope intercept form. I'm going to draw a line through the selected points, and then so here's just an example of them using that. So that is just for a line that will just do 2 points. So least squares regression line we have what we call the difference between each value and the predicted value or the residual. So they're using the golf club speed. So when you draw a line, it's not going to go through the dots exactly. There will be some that will be below the line, some that will be above. So when you subtract the actual from the predicted, you get what they call a residual value. Okay? And then, so here's just a definition of least squares regression line. Line that minimizes the sum of squares error or residuals. So you can draw several lines, but the line that makes the residuals squared the smallest, that's the one we want. So here's a little bit more definition of interpretation of least squares residual line. So this y hat, that's what they call it, v1 x, and then your intercept. v1 is referred to the residual time the change in y over the change in x. I'm going to go through those definitions. Most of this we're going to use, just do with technology. So the technology will compute it for you, because it gets pretty complicated the more you go into it. So again, we will use technology to compute this for us. So here's the definition, or a summary. I want to say this is Minitab output. So coefficient. So in the Minitab, it'll give you some output like this. This would be your intercept. This will be your slope. It gives you standard error, and it tells you like critical value and everything that we need when dealing with these problems. So interpret the slope. You got some reading here. And here's for the previous problem. This is what they say: if the club head speed increases by 1 mile per hour, the distance the golf ball travels increases by 3.1661 yards on average. So this is the idea on average, based on one increase in the explanatory variable. What is the response variable doing on average? And that's not saying every single time, but just on average. That's about the distance that's going to change. Compute the sum of square residuals. So here's a table showing you how to do all that. So we got these values and the distances. They got the slope equation. So these are like the predicted values. We're going to take each one of these and subtract. We get these residuals. You square the residuals. So this number squared will give you this. And then this is the predicted value, the residual value, and then this is the residual squared. I wanted to have it up there twice. Example 3. What's the difference in these? So this might be doing a different equation. So you can get different lines. Yeah, that's what this is showing you. You got two different equations that are predicting to be the line of best fit. So this one is showing you that if you use this equation, you get these residuals, you square them, you sum them up, this is what you get. Using this equation, take the difference between the actual value and the predicted value, you square them, add them all up, and we get 49. So it's saying that example 3, this equation is going to be a better predictor for a least squares regression line than this one. So that's the residual squared. Those are those two lines that they were just showing. And then we have how to do that with technology. So didn't give you a whole lot of information here, but I'll just explain it as we answer the problems in my math lab.